Good day everyone, I am Jun Dinisipo. Our topic for today is all about amortization and sinking fund, part of our lesson in mathematics of investments. But before we move on to the formulas and examples, let's first go over what amortization and sinking fund actually mean. These are two ways of managing money, one for paying off a debt and the other for saving toward a future obligation. First, let's define the key terms we'll be using throughout this presentation. First, amortization is a process of gradually paying off a loan through regular payments over a set period. Each payment includes both interest and a portion of principal, the amount borrowed until the loan is fully paid. Second, amortization of loan refers to the repayment of a loan through periodic payments that are equal in size, with a possible exemption of a last payment. Third, sinking fund, on the other hand, works the opposite way. It's an interest-earning account where periodic payments are made in order to accumulate a specific amount of money by a certain date, but to save for a future obligation. We also have the amortization period, which is the length of time over which a loan is scheduled to be fully repaid. And lastly, amortization schedule, a table that lists each payment period, showing how much goes to interest, how much goes to the principal, and the outstanding balance remaining after each payment. And why do we prepare an amortization schedule? Two reasons. First, to know the total interest paid, and second, to inform the borrower of the complete schedule of payments. Now, let's go over the formulas we'll use for our calculations. For the sinking fund, we have two main formulas. First, the periodic deposit, represented by A, is the amount that needs to be deposited regularly in order to reach a target future value. And second, the future value, represented by F, is the total amount accumulated in the future based on those regular deposits. For amortization, we also have two main formulas. First, the regular payment, represented by R, is the amount to be paid each period. And the present value, represented by A, sub n, is the current value of the loan or the loan amount itself. Across all these formulas, we consistently use three additional variables: I, the interest rate per period, which we get by dividing the nominal annual rate J by the number of compounding periods per year, M, and N, which is calculated by multiplying the number of years T by M. Now, let's apply these formulas to four examples. Example number 1. A loan is to be repaid through 7 quarterly payments of 8,300 each at an interest rate of 10% compounded quarterly. Let's find the value of the loan and construct an amortization schedule. For our given, N is 7 since these are quarterly payments. The nominal rate J is 10%, so the interest rate period I is 0.10 divided by 4 or 2.5%. We'll use the present value formula for amortization. A sub n equals R times the expression of 1 minus quantity of 1 plus I raised to the negative n, all divided by I. Substituting our values, we get a loan value of approximately 52,699.94 cents. Now, let's look at the amortization schedule. Notice that in each period, the outstanding principal steadily decreases, and along with it, the interest charge also gradually decreases, since there's less debt remaining. On the other hand, the portion of each payment that goes toward the principal gradually increases. By the 7th period, the outstanding principal and the final principal repayment match exactly, meaning the loan has been fully paid off. In total, the interest paid amount to 5,400.07 cents. The total payments amount to 58,100, and the total principal repaid equals to the original loan value of 52,699.94 cents. Example number 2. A 30,600 loan at 15% compounded semi-annually is to be amortized every 6 months for 3 years. Let's find the periodic payment and construct an amortization schedule. Here, our A sub n or present value is 30,600. J is 15%, so I is 0.15 divided by 2, which equals to 0.075 or 7.5% per period. M is 2 since it's semi-annual, and since this covers 3 years, N is 3 times 2 giving us 6 periods. We'll use the regular payment formula. R equals A sub N times I divided by 1 minus the quantity of 1 plus I raised to negative N. Solving this, we get a regular payment of approximately 6,519 and 17 cents every 6 months. In this amortization schedule, we again see the same pattern. Interest gradually decreases, while the portion applied to the principal gradually increases. In total, the interest amounts to 8,515.05 cents. Total payments amount to 39,115 and 0.05, and the full 30,600 principal is repaid over the 6 payment periods. A third example, a sum of 14,000 will be needed at the end of 1.5 years. If money can be invested at 12% compounded quarterly, let's find the periodic payment and construct a sinking fund schedule. Here, our S sub N or future value is 14,000. J is 12%, so I is 0.12 divided by 4, which equals to 0.03 or 3% per quarter. Since this covers 1.5 years with quarterly deposits, N is 6 periods. And we will use the periodic deposit formula for a sinking fund. R equals S sub N times I divided by 1 plus I raised to the power of N minus 1. And solving this, we get a periodic deposit of approximately 2,164.37 cents every quarter. The sinking fund schedule follows a different pattern compared to amortization. Here, the interest earned gradually increases each period since the accumulated fund keeps growing. For instance, in the first period, there's no interest yet since the deposit is brand new. But by the 6th period, interest earned reaches 344.73 cents. In total, the deposits amount to 12,986 and 22 cents. The total interest earned is 1,013 and 82 cents, and the total amount accumulated reaches the target of 14,000. For a fourth and final example, a company wants to accumulate 50,000 in 5 years to replace its equipment. If the money earns 8% compounded annually, how much should the company deposit at the end of each year? Let's construct a sinking fund schedule. Here, our F or the future value is 50,000. J is 8%, I is 0.08 since it's compounded annually, and N is 5 years. Using the same periodic deposit formula, A equals F times I divided by 1 plus I raised to N minus 1. In solving this, the company needs to deposit approximately 8,521 and 59 cents each year. In this schedule, we again see the interest earned increasing every year, from 0 in the first year up to 3,071 and 94 cents by the 5th year. In total, the deposits amount to 42,607 and 95 cents. The total interest earned is 7,384 and 82 cents, and the accumulated fund at the end of year 5 reaches the target of 50,000. Before we wrap up, I'd like to highlight the key difference between these two concepts. In amortization, we are the borrower, so each payment we make gradually reduces the principal, and the interest we pay gradually decreases because the remaining debt gets smaller. In a sinking fund, we are the saver, so the interest we earn gradually increases because the accumulated fund keeps growing. In short, amortization, the balance shrinks; sinking fund, the balance grows. Both use the concept of an annuity, but they move in opposite directions. That concludes our presentation on amortization and sinking fund. We hope this helped clarify how regular payments are calculated, whether for repaying a loan or saving for a future need. Thank you everyone for listening. God bless us all.